Hello everyone. Now today I'll discuss with you in this session about the chapter metals and non-metals and the chemical properties of metals and non-metals. Now in the previous session I have discussed with you about the physical properties of metals and non-metals, and we have observed that there are so many exceptions. Exceptions like that if I say that metals are hard, but sodium and potassium, these are the metals that are very soft. But if that we have observed in the case of non-metal also, that if non-metals are poor conductor of electricity, but what about graphite, that is an allotrope of carbon, is a good conductor of electricity. And metals generally are hard, but what about mercury, that is a metal but that exists in liquid state. Non-metals, if I say non-metals are soft, but diamond, the allotrope of carbon, that is the what? That is the hardest substance known. Now, on the basis of physical properties, we can't rely only and only on the physical properties of metals because of so many exceptions. Now today in this session I'll discuss with you about the chemical properties of metals, how metals react with other substances like oxygen, like water, like acids, hydrochloric acids. Now first I am discussing about reaction of metals with oxygen, that how metals react with oxygen. Now, almost all metals react with oxygen, and what is the general reaction when metals react with oxygen? That is, when metal react with oxygen, what the product will be formed? Metal oxide. Now let us do some example. If I say magnesium, now one more thing I want to tell you that all the metals do not react with oxygen at the same rate. If I talk about the sodium, the most reactive, sodium, the reactive metal, that if it react with oxygen, in the room temperature, that if sodium metal comes in contact, sodium and potassium both, they come in contact with the oxygen, they immediately catch the fire. Now if I have to write the reaction, sodium react with oxygen, I say metal oxide. It means I have to write here what is formed? Sodium oxide. What is formed here? Sodium oxide, and it will react at room temperature. And now I will tell you about the zinc. Zinc on strong heating. Now few metals react at the room temperature, that highly reactive metals, sodium and potassium. Zinc, when we heat the zinc, strong heating, then it will react with oxygen and it forms zinc oxide, but on strong heating. And then magnesium, again on heating, react with oxygen, it burn with a white dazzling flame and form magnesium oxide. Metal oxide means it form magnesium, react with oxygen and form magnesium oxide. And here aluminium, again aluminium react with oxygen and form aluminium oxide, Al2O3, that is aluminium oxide. Now aluminium is like that when we keep the aluminium, when aluminium comes in contact with the oxygen, a layer of oxide is formed over it, and that layer of oxide prevent the further corrosion of metals. Like this, aluminium react with oxygen. Now copper, that on prolonged heating, when we heat copper for a long period of time, then it will form copper oxide. A black color layer is formed, black color coating is over here, that is of copper oxide. In this way, these all metals react with oxygen. Now iron is comparatively less reactive, and iron when react with oxygen, then what it form? It form Fe3O4. Fe3O4, that is the ferroferric oxide, or you can say Fe3O4 is what? That is the FeO.Fe2O3 iron second third oxide. You can write it like this also. Now the next The last, silver, Ag and gold. Silver and gold do not react with oxygen. If you look at the reactivity series, they are the least reactive metals and they do not react with oxygen. In this way, we can say that metals react with oxygen, but they don't react with oxygen at the same rate. Now I will tell you about what is the nature of metal oxide. Yes, children. Now we have discussed about when metals react with oxygen, they form metal oxide. Now what is the nature of metal oxide? For example, if we burn a magnesium ribbon, and magnesium when react with oxygen, I have told you that form magnesium oxide. White color ash of magnesium oxide is formed. Now if in this magnesium oxide, I'll put some water and I'll check it with the help of litmus paper. Then what I observe that red litmus turn blue. Red litmus turns blue. It means the metal oxides are of which nature? Metal oxides are basic in nature. As we compare it with the non-metal oxide, if I say SO2, that is of which nature? That is of acidic nature. So you can write one more difference here, that metal oxides are basic in nature and non-metal oxides are acidic in nature. But there are very important question of this chapter. There are some metal oxides that show both acidic as well as basic behavior. जो दोनों behavior show करेंगे, they react with the acid also, they react with the base also. Both the behavior they will show. Then the metals that show metal oxide, not metal, the oxides of metals that show both acidic as well as basic behavior, these are called, what they are called? They are called amphoteric oxide. They are called amphoteric oxide. Then this is again the question that is frequently asked from this chapter. What are amphoteric oxides? So what you will write, the amphoteric oxides are those metal oxides that show both acidic as well as which behavior? Acidic as well as basic behavior. And the two examples of these amphoteric oxides are, number one, aluminium oxide, that is Al2O3, and zinc oxide, that is ZnO. Now let us see how they react with acid and base. Now aluminium oxide, Al2O3, as it reacts with acid, HCl, what it forms? AlCl3, aluminium chloride and water. And this Al2O3 with NaOH, it forms sodium aluminate and water, NaAlO2. This, and now the example of zinc oxide, as I told you the two examples as aluminium oxide and zinc oxide. Now I am showing the zinc oxide with hydrochloric acid and sodium hydroxide. As zinc oxide react with hydrochloric acid, it forms ZnCl2, zinc chloride and water, and as it react with NaOH, it forms sodium zincate, Na2ZnO2 and water. So this two examples you can write with the amphoteric oxide. Ampho means both, that show both acidic as well as basic behavior. Now few oxides of metal. If I say sodium, oxides of sodium, Na2O, oxide of potassium, K2O, oxide of magnesium, MgO, they dissolve in water. And form water soluble bases. Water soluble bases are called alkalis. So you can also keep it in mind that few oxides of metal, these are highly reactive metals, Na2O, K2O, MgO. When they react with water, they form alkali NaOH. Na2O react with water, NaOH. K2O react with water, KOH. And if I say magnesium, MgO, MgO, magnesium oxide, when it reacts with water, it forms magnesium hydroxide. This is all about the nature of metal oxides. Yes, children. Now the next reaction, reaction of metal with water. Now, when metals react with water, they form metal hydroxide and what is released? Hydrogen gas. Hydrogen gas. Now, let us do one example. Now, potassium react with water. It forms potassium hydroxide and hydrogen gas is released. Now, sodium, the most reactive. As I have told you, when the metals react with oxygen, all metals do not react with oxygen at the same rate. Similarly, when metals react with water, the rate of reaction with water is not same. These two metals, highly reactive metals, sodium and potassium, they react with even with cold water. As they react, what they form? They form hydroxide. Like potassium react with water, form potassium hydroxide, KOH, and hydrogen gas is released. Similarly, sodium react with water and form what it form? Sodium hydroxide and hydrogen gas is released. And calcium again, calcium react with water. Now you can tell it very easily, it forms calcium hydroxide, CaOH twice and hydrogen. And magnesium again react with water and form magnesium hydroxide and hydrogen gas is produced. Now there is a very interesting fact about these calcium and magnesium, that here the calcium react with water like sodium and potassium, but the magnesium on heating, it react with the boiling water and then it form magnesium hydroxide. Now these two metals, calcium and magnesium, what happened during the reaction? When they react with the water, they start, these two metals, calcium and magnesium, what they start floating on the surface of water. Why? This is again the questions asked in the question, why calcium and magnesium start floating in water when they react with water? Because hydrogen here produced get stick to their surface and that make them to float on the water. कि जो यहाँ hydrogen produce होगी, जो hydrogen के bubbles होंगे during the reaction of calcium with water and magnesium with water, these bubbles of hydrogen get stick to the surface of these metals and make them float on the surface of water. Now the next is what? Next is that these metals, aluminium, Al, iron and zinc. Aluminium, iron and zinc, they do not react with the cold water. Even they react with steam. Now here you will note that when these metals react with steam, they do not produce metal hydroxide. In fact, they produce what the product will form? Metal oxide. Keep it in mind always, these three metals, aluminium, iron and zinc. These are the, if you say the reactivity series, these metals are at the top of the reactivity series and when they react with water, they form metal hydroxide. But these aluminium, iron and zinc, then what they form, they are the middle, they are in the middle of the reactivity series. They do not react with the cold water, they react with steam, and when they react with steam, no doubt hydrogen gas is produced, but at the place of magnesium hydroxide, metal oxide will be formed. Metal oxide. Now let us see one example. Aluminium, when react with, I have written here the balanced equation. Always keep in mind that whatever reaction you are writing, whether in the chapter 1, chapter 2, chapter 3, always write balanced, well balanced chemical equation. Now here aluminium, water react with water and form aluminium oxide, because here you can write here with water that is the G means that it react with the gaseous state of water, and that gaseous state of water is steam. Now aluminium oxide Al2O3 and hydrogen, and about the iron Fe react with water and form ferroferric oxide and H2, and this Fe3O4 contains FeO and Fe2O3 iron in second and the third oxidation state, and we write it like this Fe3O4 and H2. Now these two reactions are again very important, that what happened when aluminium and iron react with water. You will keep in mind they do not react with the cold water, they react with steam. Now what about the metals that are having the very they are very less reactive, that at the bottom of the reactivity series, like lead, copper, gold and silver, they do not react with water. This is how the metal react with water. Yes. Now next reaction of metal with dilute acids. Now when metals react with dilute acid, what is the general reaction? Metals react with dilute acid. What they form? They form metal salt, and what else is formed? Is hydrogen gas is released. Now let us see one example. I am giving here the example of few metals. When react with dilute acid, here I am giving the example of sodium. When sodium react with hydrochloric acid, dilute HCl, what it forms? I have told you metal salt, that is NaCl. Metal here is Na, acid here is HCl, and metal salt form is NaCl, sodium chloride, and hydrogen gas is released. Now the next I am giving you the example of magnesium. I here the magnesium at the place of HCl I have taken the acid sulfuric acid, that is H2SO4. Now when magnesium react with H2SO4, that is sulfuric acid, what is formed? MgSO4, magnesium sulfate, and hydrogen gas is released. Now calcium when react with hydrochloric acid, what it form? It form calcium chloride and hydrogen gas is released. You always have to keep in mind the general reaction, that what happened when these two react with metal, then the what is formed? Acid react with metal salt and hydrogen. Then you can write various examples. Now here one more thing I want to tell you, that the metals, this is the reactivity series, activity series. Now when metals are arranged in order of their decreasing reactivity, I am saying decreasing reactivity decrease हो रही है as we move from top to bottom. This is called, this arrangement of metal, they are arranged in a decreasing order of their reactivity. This is called activity series. Here this hydrogen, the metals that are below the hydrogen, they will not react with what? They will not react with acids like copper, silver, and here gold. They do not react with what? They do not react with hydrogen. Right, fine. Now here is what? The next is what? Here the one more acid is there, that is nitric acid. Now one more interesting fact about this, that if the metal react with hydrochloric acid, if the metal react with sulfuric acid, there is one more acid that is called nitric acid or HNO3. Metals do not react with nitric acid. Again, very important question of this chapter. Why do metals do not react with nitric acid? What is the reason behind that? That this nitric acid is a strong oxidizing. This is oxidizing agent, And when metals react with acid, I have told you hydrogen gas is produced. Now this nitric acid, it will oxidize the hydrogen produced here to water and it itself get reduced. It itself get reduced. क्या होता है कि नाइट्रिक एसिड मेटल्स के साथ रिएक्ट नहीं करता. क्यों नहीं करता? बिकॉज दिस नाइट्रिक एसिड इज द एक्ट एज एन ऑक्सीडाइजिंग एजेंट एंड जो हाइड्रोजन यहाँ पर प्रोड्यूस होगी उसको ऑक्सीडाइज कर देगा वाटर में और खुद itself it get reduced to oxide of nitrogen like NO2, nitrogen dioxide. It itself get reduced to the oxides of nitrogen and oxidize what hydrogen here produced to water. That's why hydrogen gas will not produce when these metals react with what? React with nitric acid. But there are again two metals like magnesium and manganese. Again, important point of this, important question of this chapter. Name two metals and show their chemical reaction when metals react with nitric acid. Rest metals will not react with nitric acid. Which two metals react with nitric acid? First is magnesium and other is manganese. Now magnesium when react with nitric acid, it react with very dilute nitric acid and it will form MgNO3 tries magnesium nitrate and then the hydrogen gas is produced. You can also give the example of manganese. Now manganese react with nitric acid, very dilute nitric acid and it will form MnNO3 twice and hydrogen gas is released. In this way, this is a very important question of this chapter. Why metals do not react with nitric acid? You will give this answer that nitric acid is an oxidizing agent and this oxidizing agent that hydrogen produced get oxidized to water and itself it get reduced to the oxide of nitrogen like nitrogen dioxide. But two metals that react with nitric acid, that magnesium and manganese. Fine. This is how the metals react with dilute acid. Now the next is how metals react with solution of other metal salt. This is another reaction, that reaction of metal with the solution of other metal salt. Like if I say metal zinc react with copper sulfate. This is the solution of the copper, that is blue color copper sulfate, and when they react here you can check it with the help of reactivity series. Here it is like what? It is like the which reaction? It is like the displacement reaction. Displacement reaction means that highly reactive metal will displace the least reactive metal from its salt solution. Let us check how. Now here zinc when put in the solution of copper sulfate, this blue color, the color of the copper sulfate is blue. When the reaction will take place, here in the reactivity series you can check that zinc here is more reactive than copper. Zinc here is what? This is more reactive than copper. Fine. Now zinc when put in the solution of copper sulfate, now this zinc will displace the copper from the copper sulfate and form zinc sulfate and copper is formed. Now here what happened? The blue color of the copper sulfate when react with zinc, what happened? The blue color of the copper sulfate will get fade or disappear. One more reaction. If I take a beaker, in that beaker I will put copper sulfate and few iron filings. What happened? Again you can check from the reactivity series that iron is more reactive than copper. Now if the iron is more reactive than copper, it will take the place of, it will displace the less reactive metal from copper sulfate and form FeSO4. that is and what copper copper is remain here in the solution. Now what happened, this blue color of copper sulfate after the formation of what, after the formation of ferrous sulfate, that is FeSO4, turns into light green color. This is again question asked, why the blue color of copper sulfate turns green when we put iron in it. Then what is the reason? At the highly reactive matter of iron will displace the copper and form ferrous sulfate FeSO4, and this gives the solution a light green color. This is all about the reaction of matters with various other substances like oxygen, like water, like matters of the other salt solutions, and then we have done how they react with the dilute acid. Now again there is a term of this chapter. What is aqua regia? What is aqua regia? Now this aqua regia is the freshly prepared solution having what? Concentrated. Which acid? Concentrated HCl plus HNO3. Mixture of concentrated hydrochloric acid and nitric acid in the 3:1, and this aqua regia can dissolve a metal, that is gold metal इसमें dissolve हो सकती है, and also it can dissolve the platinum also. This is that is the aqua regia. This is all about these properties of metal. Thank you.